Welcome, future cybersecurity explorers. Whether you're just starting out or already have some experience, you're about to take an exciting step into the world of ethical hacking and digital security. Today, we're going to guide you through building your very own hacking lab, a safe, personal playground where you can learn, experiment, and grow your skills in ethical hacking. This isn't just any workspace. It's a dedicated environment designed for hands-on learning, right from the comfort of your home. Ethical hacking is all about understanding how computer systems work so you can protect them from threats. It's not about breaking into systems for malicious reasons, but about learning how to defend and secure them. By thinking like a hacker, you'll become a better defender. Imagine your lab as a digital science lab, a controlled, risk-free space where you can safely experiment, break things, and then fix them. Here, you can try out new tools, test your ideas, and make mistakes without any danger to real-world systems or data. You'll be using virtual machines, software-based computers that run inside your main computer. This means you can set up different operating systems, simulate networks, and practice attacks and defenses, all without needing expensive hardware or risking your main system. This lab is your personal training ground. Here, you'll gain real, practical experience and build the confidence you need to tackle real-world cybersecurity challenges. The skills you develop here will set you apart from those who only read about hacking or watch videos. And don't worry if it sounds complicated or overwhelming. We'll be using free, open-source tools and breaking everything down into simple, easy-to-follow steps. No expensive software or advanced knowledge required, just curiosity and a willingness to learn. So, are you ready to build your digital playground? Let's get started together. Your journey into ethical hacking and cybersecurity begins right now. Before we dive in, let's talk about the hardware you'll need to set up your own lab environment. Having the right equipment is the foundation for a smooth and enjoyable experience, so let's make sure you're prepared. First, you'll need a computer. This can be a desktop or a laptop, and it doesn't matter if you're using Windows, Mac, or Linux. Any of these operating systems will work for our purposes. The key is to use a machine that you're comfortable with and that meets a few basic requirements. Your computer should be modern enough to handle running a couple of virtual machines at the same time. Ideally, you'll want at least a quad-core CPU, which means your processor has 4 or more cores to handle multiple tasks efficiently. For memory, 8 GB of RAM is the minimum. But if you can get 16 GB or more, you'll have a much smoother experience, especially when multitasking or running resource-intensive applications. Storage is another important factor. You'll want to have between 50 and 100 gigabytes of free space available. This space will be used for your virtual machines, software, and any files you create during your experiments. If possible, use a solid-state drive, or SSD, instead of a traditional hard drive. A reliable internet connection is also essential, at least for the initial setup. You'll need to download software, updates, and possibly some large files. To check your computer's specs, on Windows, go to Settings, then System, and click on About. On a Mac, just click the Apple menu and select About this Mac. This will show you your processor, memory, and storage information so you can be sure your system is ready. That's really all you need to get started. A computer with enough power, some free storage, and a decent internet connection for setup. Once your hardware is ready, we'll move on to installing the software you'll need to bring your lab to life. The process is straightforward, and I'll guide you every step of the way. Now, let's gather the software. Everything we'll use is free and industry standard. First, you need a hypervisor, software that lets you run virtual machines. We'll use Oracle VM VirtualBox, which works on all major operating systems. Next, download Kali Linux, a security-focused OS packed with hacking tools. For a safe target, we'll use Metasploitable, a purposely vulnerable virtual machine. Download VirtualBox from virtualbox.org, Kali Linux from kali.org, and Metasploitable from Rapid7's site. Always use official sources to avoid malware. With VirtualBox, Kali Linux, and Metasploitable, you'll have a complete self-contained hacking lab. No need to spend a dime. Ready to build? Let's get started with VirtualBox. Your toolkit is set. Time to install. Let's install VirtualBox, the foundation of your lab. Go to virtualbox.org, download the installer for your operating system, and run it. Accept the default settings. No need to change anything. If prompted, allow network drivers to install. They let your virtual machines communicate. The process takes just a few minutes. When finished, launch VirtualBox. you'll see the VirtualBox Manager. This is where you'll create and manage your virtual machines. It might look empty now, but not for long. You've completed the first major step. Next, we'll set up your attacker machine, Kali Linux. Ready to keep building? Let's go. It's time to set up your attacker machine using Kali Linux, the go-to operating system for cybersecurity professionals and ethical hackers. Kali Linux comes preloaded with hundreds of powerful tools designed for penetration testing, digital forensics, and security research. By setting up Kali as a virtual machine, you'll be able to experiment and learn in a safe, isolated environment without risking your main computer. Start by downloading the Kali Linux VirtualBox image, also known as the OVA file, directly from the official kali.org website. Always use the official site to ensure you're getting a secure, up-to-date version. Save the file somewhere easy to find, like your desktop or Downloads folder. Open VirtualBox, then go to File and select Import Appliance. Browse to the OVA file you just downloaded, select it, and click Next. This process will create a new virtual machine with all the necessary settings pre-configured for Kali Linux. Take a moment to review the default settings. If your computer has 16 GB of RAM or more, it's a good idea to allocate 4 GB to Kali for smoother performance. If you have less memory, leaving it at 2 GB is perfectly fine for most tasks. You can also adjust other settings like CPU cores if you want to optimize performance further. Under the Network tab, make sure Adapter 1 is set to NAT. This setting allows your Kali machine to access the internet through your host computer, which is essential for downloading updates and tools. Click OK to save your changes, then hit Start to boot up Kali Linux for the first time. You'll see the familiar Kali login screen as the virtual machine powers up. Ready to move forward? Let's set up Metasploitable, a vulnerable virtual machine designed specifically for practicing penetration testing techniques. This is where the real fun begins. Now let's add your target, Metasploitable. Download the Metasploitable zippy from Rapid7, extract it, and find the .vmdk file. In VirtualBox, click New, name it Metasploitable, set type to Linux and version to Ubuntu, 64-bit. Assign 512 MB, 1 GB RAM. For the hard disk, choose Use an existing virtual hard disk file and select the .vmdk file. Click Create. Before starting, go to Settings on Network and set Adapter 1 to Internal Network, name IntNet. Do the same for your Kali machine. Change its Adapter 1 to Internal Network, IntNet. This isolates your lab from the internet and your home network. Now, start both Kali and Metasploitable. You have a safe, private environment for practice. Your hacking lab is ready for action. Let's learn how to use it safely. On to the next step. Your lab is live and isolated. Time to practice. Log into Metasploitable, user msfadmin, pass msfadmin, and run to find its IP address. Log into Kali, user Kali, pass Kali, open a terminal, and run for its IP. Both should be on the same network. Test the connection. In Kali, type. If you get replies, your machines can talk. Start with Nmap in Kali. Run to scan for open services. Use the results to research vulnerabilities, always on your own machines. Try tools like Metasploit to practice exploiting safely. This is how real pros learn, discover, research, and test in a safe space. Never attack systems you don't own. Your lab is for learning and growth. Ready to level up? Let's talk about ethics. With great power comes great responsibility. Only use your hacking skills on systems you own or have written permission to test, never on others. Even simple scans on unauthorized systems can be illegal. Your lab is your safe zone. Everything outside it is off limits. The goal is to learn, defend, and help, not harm. Stay curious about both technical skills and ethical guidelines. Build your reputation by always doing the right thing. Congratulations! You've built a real hacking lab and taken your first step into cybersecurity. Don't be afraid to experiment. Mistakes are learning opportunities. Use VirtualBox snapshots to save your progress and recover from errors. Explore platforms like TryHackMe and Hack the Box for more challenges. Watch tutorials, dive into topics that excite you, and keep practicing. Cybersecurity is always evolving. There's always something new to learn. Be patient, celebrate your progress, and stay curious. Your lab is a launchpad for your future. Whether you want to be a pro or just understand the digital world, you now have the tools to start. Keep exploring, keep learning, and have fun.